Welcome back to grade 12 Euclidean Geometry. Today we will look at area ratios, how to distinguish between type 1 and type 2. For this lesson I am going to focus on page 240, starting on page 240. I am working from the Mind Action Series textbook. You can find the link on my channel if you are interested in downloading a sample copy of this textbook. So on page 240 we encounter two types of areas that we can use, or area ratios that we should be able to distinguish when working through exam examples. So the first type is where we have a triangle with the same perpendicular height. And what we realize from type 1 is that the ratio of the areas should be equal to the ratio of their bases. So what I'm saying is that the area of triangle ACP, so I can highlight that for you, the area of triangle ACP over the area of triangle ABP would be equal to the ratios of their bases. So it's going to be the base value of the blue triangle over the base value of my yellow triangle. And let's get practical. Let's do an example just to consolidate this. So if I give you the following triangle, I have triangle ABC, and there's another line AP, and given to us is the following, that BP to PC is a 3:5 ratio. Normally what I do is I would just convert that and incorporate a variable like x, because these are not actual lengths, they are just a simplified ratio of the lengths. So if it's 3:5, on my sketch I'm going to change that to 3x and to 5x. Okay, so x can be any real number essentially. If they want you to find the area of triangle ACP over ABP, let's use different colors again. So let's say ACP is my blue triangle. I want that ratio over my yellow triangle, which is ABP, the same as what we did before. It now changes to the following. We can say that the blue triangle has a base of 5x, yellow triangle has a base of 3x, and that simplifies to 5 over 3. Just something that I want to highlight or draw your attention to is the fact that this is a type 1 triangle, in the sense that they share the same common height. We don't know what the height is, we also don't care, because it will cancel out once you work out the areas. Okay, so this is on page 240 if you want to refer back to that. Type 2 is when we have a common angle and parallel lines. So in this case we have PQ is parallel to BC, and the common angle would be A. I'm going to illustrate this in my Let's Get Practical example. So given to us is our parallel lines, and also given to us is the following ratio. AP to BP is 4:5. Again, I'm using blue to show you that this is a simplified ratio. It is not the actual lengths of the sides. AP is therefore 4x and BP is 5x, x being any real number. Now because we have parallel lines and we have a parallel line drawn to one side of the triangle, we can say that the ratio of AQ to QC would also be equal to 4:5, but I'm going to change that and make it 4y to 5y. 4y to 5y, y also being any real number. The reason why I can't say it's 4:5 is because it's not an actual length. We just know that the triangle it's the proportionality theorem, so it cuts the triangle in the same ratios. Right, so once we have that, please provide a reason. Line parallel to one side of triangle. And when they get to the question, find the area of triangle APQ to the area of triangle ABC, we are now going to say, oh, I never actually wrote the rule down. The rule is that if you need to find the area of the small triangle, which is triangle APQ, over the big triangle, which is triangle ABC, then you can say that it would equal the sides squared over sides squared. I'm going to make that more practical. We are looking at blue and green sides, and they share parallel lines as well as a common angle. So this is a type 2 example. We are going to say to find the area of triangle APQ. You can take 4x, multiply that by 4y. What am I doing? It's this side multiplied by that side over the area of the bigger triangle, which would be 9x times 9y. So graphically, it's going to be AB, which is 9x because it's 4x plus 5x, times 9y because it's 4y plus 5y. Essentially what it boils down to is 4 squared over 9 squared, because the x's and y's will cancel, and that will give you 16 over 81. Great. Let's do a textbook example just to, tattoo that into our brains. I am working on page 244, example C in the Mind Action Series textbook. You can find the sample textbooks by following the link on my channel. So in the sketch alongside we have the following triangle, and it is given to us that the lines BR and CD are parallel. I made that in bold for you just to really see and understand. Also given to us is BC is equal to 5 over 13 BQ, and PB is equal to BQ. Now I really want to just take that information and make it more usable or user-friendly, because at the moment it's not so user-friendly. So when I take this, I'm going to divide both sides by BQ, and then I'll get BC over BQ is 5 over 13. Normally when I take out my blue pen, it means I am adding a variable like x, and now I can fill that into my sketch. 5x, BQ is 13x, but for that reason CQ is 8x, because 5 plus 8 gives you 13. Okay, I'm going to use this piece of information in my last question, or my fourth question, I think. Okay, so when we get back to the question, they want the area of triangle CQD, that's blue, over the area of triangle BQR, and that is green. We identify this as a type 2 triangle. Why? Because we have a common angle. The common angle is angle Q for both triangles, and we have parallel lines in bold. Now the first thing that I would do is I would now activate my green pen and say, well, because we are working within parallel lines, I can say that QD over DR would equal 8y, originating from the 8x, over 5y, originating from the 5x. I'd have to write that down more specifically and say, listen, QD over DR is equal to 8y over 5y, line parallel to one side of triangle. Once I have that, I can proceed, because I've now provided a reason that I can use throughout the rest of the question. Great, so it's type 2, and if that is the case, it means that I will take the sides of my green triangle adjacent to the common angle, and that would be the 8x and 8y. I would multiply them together. Let me use the colors. 8x times 8y over, so that's for my small triangle, the blue triangle, over big triangle is BQR, that's my green triangle. That would be 13x times 13y. Where does the 13y come from? 5y plus 8y gives me 13y. So essentially what I'm saying is it becomes 8 squared over 13 squared. That gives me 64 over 169. That's your final answer. Let me put a little frame around it for you to remember. Great. So that concludes the first question. For the second question, we are asking what would the ratio be of the red over the yellow triangles? So I've used colors just to simplify this for us, to make it quicker. So the red triangle and the yellow triangle do not share a common angle, but they do share a common, I like to call it like a baseline. You can see that they have like a common baseline, and they share a common perpendicular height not drawn. But we can draw a perpendicular height if we wanted to. So this makes it a type 1 triangle. Okay. For that reason, we will say that the area of the triangles would be equal to the area, or the ratio of the bases rather, which means I can use the red base over the yellow base. For this, I am going to refer back to my question above, where the red base can be seen as 8y. Can you see? That's the red base, because it's from D to Q. And then the yellow base would equal 5y, because that would be from R to D. Okay, so it simplifies to the ratio of their bases being 8y over 5y. We omit the y. We simply get 8 over 5, and that concludes the second question. For the third question, we do have a little star because things will get difficult from here onwards. So for question 3, I'm working with a blue and a purple triangle. I've used the blue triangle before, so I'm usually very consistent with the colors that I use. And for the blue triangle, I've used that in question 1. I might need it for this question. Let's see. Okay, so we have the area of the blue triangle over the area of our purple triangle. In this case, it is neither type 1 nor type 2. Why? Because they don't share a common height, and they also, yes, they share a common angle, but CD is not parallel to PR, so I can't say it is type 2. If this is the case, normally you would have to combine the answers from the questions above to help you with this. So what I would do is I would identify PQ as my, what do I call it, baseline. Let me just put a little border around for us to really know this is super NB. Okay, so that's my baseline is PQ. Okay, and I'm going back to the first question. I have a ratio for blue over green. I'm going to use my green pencil here to show you how this helps me. So if this is my green triangle, I'm only using a portion of my green triangle. So I want you to first find, this is so important, first find the ratio of the green triangle over the purple triangle. First do that. And this is going to make it easier. Why? I'll show you now. Oops, wrong pen. Sorry guys, wrong pen. There we go. Okay, first find green, that is triangle BRQ, over purple, which is triangle PQR. First do that. Now this means it is, in this case, it would be a type 1 triangle where they share a common height. Let me just draw that height in for you to fully understand. This is the perpendicular height. They share a common baseline, as I said. Okay, so then it means it reduces to the ratio of their bases, and that would be BQ over, so that is the base of the green triangle, over PB, which is the base of the purple triangle. Have a look at that. Great. Now BQ is equal to not PB, that's supposed to be PQ, apologies. PQ is the base of the purple triangle. Now BQ is equal to PB, and BQ is also equal to 13 x, so I'm going to indicate that 13x on my sketch. 13x BQ, and given to me right at the top is the fact that PB is also 13x, and that means the whole PQ is equal to 26x. So that reduces to a half. That's easy enough. But what's important here is that we are not using the whole green triangle. The green triangle was never part of the question. We are interested in the blue triangle. Now the blue triangle is only a portion of the green triangle. And what portion are we working with? The portion that we have identified in the first question. So we're asking what portion is the blue triangle of the green triangle? Let's go back. The blue triangle over the green triangle gives us a simplified ratio of 64 over 169. So I'm going to just write this down again. This gives us the simplified ratio of blue over green. I am going to use this in the next question, in this question that we are busy with. I'm reminding you that the blue over green is equal to 64 over 169. And considering that we are not using the whole green triangle, we are going to multiply the green part of my question with the ratio 64 over 169 over 2. And that would give you your final answer. And that should give you 32 over 169. Whew, that's a lot of information to process. Let's carry on to question 4. Remember, you can pause and go back at any stage. For question 4, another star indicated. So in this case, we are trying to find the area of blue over red. I've worked with blue before. I think I've worked with red before. This one's actually fine to do. In this case, I'm just going to include the 13x. That is PB. This is 5x. And then this is 13x again. Not 13, I'm lying. 8x. I'm going to need this for this question. So this is a type 2 example. No, type 1 example because they share a common height. Let me draw that for you. This is the common height that the two triangles share. They also share a common baseline. I'm going to move my sketch up a little bit just so that everyone can see what I mean. The common baseline that I like to call it. This is the common baseline, which means both of the bases can be found on this line, which is line PQ. So because it's type 1, it means that the area of blue over area of red would equal the ratios of their bases. So I'm going to put the base of my blue triangle, which is what is asked of me, over the base of my red triangle. Base of blue is 8x. Base of red is the 13 plus the 5 plus the 8, which is 26. We worked with that just before. And if you simplify, you will get 4 over 13. So because they share a common height, their areas can be reduced to the ratios of their bases as long as they share a common height. Okay, who's ready for question 5? This is the last one for this specific example. It is the most difficult one. I hope that you are ready. Okay, so now they're asking what is the ratio of blue over yellow. This is, again, neither type, it's neither type 1 nor type 2, which means we need to combine answers from above to help us with this one. So the blue triangle we have worked with before, and we've also worked with the yellow triangle. Now I've already prepped this question for us. Something that I want you to remember is that in a previous question, I think this was question, let me just quickly pop back, it was question 2. In question 2, we found the ratio of red over yellow, And the ratio of red over yellow, let me just get that again, was 8 over 5. So I'm going to put that in over there, 8 over 5. Now, I'm not using the whole red triangle. So what I'm saying here is that I'm only using a portion of red triangle. I'm only going to use a portion of that red triangle. I'm not going to use the whole one because they don't want the whole one. They only want the blue part. So now I'm going back to another question that I did. I think this was the question just prior to this one. This was question 4. So in question 4, we found the ratio of blue over red. Now I'm interested in that because that would help me to solve question 5. So blue over red, we said, was equal to 4 over 13. How does this help me? Because 4 over 13 represents the portion of red triangle that I'm going to use. Okay, so the portion of the red triangle is equal to the blue triangle, and that portion is 4 over 13. So if I start this question off and say, okay, I'm interested in blue over yellow, I'm first going to rewrite the ratio of red over yellow as below. First going to rewrite red over yellow as if I'm trying to find red over yellow. I'm not, I already have that. But red over yellow is equal to 8 over 5. I'm not going to use the whole of the 8. I'm only going to use a portion of my red triangle. The portion of the red triangle that I'm using is the 4 over 13. Because the 4 over 13 is the fraction or the ratio of blue triangle over red triangle. So for that reason, I'm taking the 8 and multiplying it by 4 over 13. That's the portion of the red triangle that I'm using. So it's sort of like simultaneously solving your equations. If you pop that into your calculator, you will get a simplified answer of 32 over 65. That's the end of my lesson. Stay tuned for the next part that we will do. We are following the Mind Action Series textbook examples. I hope this helps. Remember to like my video and subscribe to my channel if you found this video helpful.